Scene script. Have you ever wondered why your compass needle always points north? Many believe it's because Earth is a giant magnet. Is it really so? We've all been taught in school that our planet behaves like a colossal magnet, with a north and south pole. And this magnetic field is what makes compasses point north. It's a comforting thought, isn't it? But what if I told you this is a common misconception? Truth be told, the Earth's magnetic field is surprisingly weak, measuring only 6 Gauss along the equator and a meager 2 Gauss in the imaginary space extending to space. And no, contrary to popular belief, our planet doesn't have a protective magnetic field extending to space, shielding us from solar wind radiation. So why does the compass point north? It's due to the weak current induced by moving sunlight and the Earth's rotation, not because the Earth is a super powerful magnet. Let's dive in and debunk some of these myths about Earth's magnetic field. One widespread belief is that Earth has a magnetic core that produces a magnetic field. Is this the truth? Well, let's delve into it. The Earth's core is indeed made up of iron and nickel, but it doesn't produce a magnetic field as we often visualize it. Instead, the magnetic field originates from the geodynamo effect, a process that involves the movement of molten iron within Earth's outer core. This movement generates electric currents, which in turn produce the magnetic field. It's a fascinating process, and it's not as straightforward as simply saying that the Earth has a magnetic core. In reality, our planet's magnetic field is a result of a complex interplay between heat, rotation, and electric currents. So, to sum it up, the Earth's core does play a role in generating the magnetic field, but it isn't inherently magnetic itself. So, Earth does not have a magnetic core, but it does have a magnetic field. What about the strength of Earth's magnetic field? Is it as strong as we think it is? Let's delve into this question. There's a common belief that our planet is enveloped in a robust magnetic field, but in reality, it's not as formidable as it's often made out to be. The strength of Earth's magnetic field is relatively weak. Imagine, if you will, a measuring scale called Gauss. Now, along the equator, the magnetic field only measures about 6 Gauss. That's right, just 6. And if we move into the imaginary space extending into space, it drops even further to a mere 2 Gauss. So, the magnetic force that guides our compass needles, that we've grown up believing to be this powerful force, is actually quite gentle. It's a subtle whisper in the cosmic conversation, not the thunderous roar we often picture. So the Earth's magnetic field is not as strong as we often think. And what about the idea that Earth's magnetic field extends to space to protect us from solar wind radiation? This is a common belief that many people hold. However, it's not entirely accurate. The Earth's magnetic field is not a superhero shield, fending off the harmful solar wind radiation. Rather, it operates more subtly. The Earth's magnetic field is weak, particularly when it comes to interacting with the vast expanse of space. It measures only around 2 Gauss in the imaginary space extending towards the cosmos. This is hardly enough to act as a robust shield against the onslaught of solar wind radiation. What then, you may ask, is the role of Earth's magnetic field? It's believed that the magnetic field helps to guide certain processes on Earth, such as the direction in which a compass needle points. So, contrary to popular belief, Earth's magnetic field does not extend to space as a protective shield. We've debunked some common misconceptions about Earth's magnetic field today. The truth is, our planet is not a colossal magnet as we've been led to believe. It neither houses a magnetic core, nor does it boast a magnetic field of formidable strength. The measured strength of this field is a mere 6 Gauss at the equator, and drops to a paltry 2 Gauss as we move towards the ethereal expanses of space. The assumption that our planet's magnetic field extends to the far reaches of space, acting as a protective shield, is indeed a scientific fallacy. The reality is much simpler, and perhaps more fascinating. The northward direction of the compass needle isn't due to the Earth's magnetic prowess, but is influenced by the weak current induced by the movement of sunlight and the rotation of Earth. So, let's set the record straight. Next time you see your compass needle pointing north, remember, it's not because Earth is a giant magnet,